Hello everyone and welcome back to my YouTube channel. My name is Pauline the Analyst and today we're tackling one of the most powerful SQL techniques, and that is the self join. Have you ever needed to compare rows within the same table? Maybe find employees with the same manager or even products in the same category. That is where the self join comes in. So by the end of this video, you will be able to know exactly when and how to use it. So let's get started. So in this new video, we are going to cover 1. What a self join is and why it's different from other joins. 2. Setting up a real-world example using an employees table. 3. Writing a self-join query with live demo. 4. Finding hierarchical relationships like manager-employee structures. And finally, pro tips and real-world use cases. So let's dive in. So in our new segment, we are going to understand what self-join is. A self-join lets you link a table to itself to reveal hidden relationships. So in our next segment, I want us to set up our table. Let's create an employees table where each employee has a manager who's also an employee. This is perfect for self-join. So let's write it down. The employees table with manager ID referencing employee ID. So we'll write create table and we are creating the employees table. And then in this table, it has columns. So the first column will be the employee ID. And since it's a number, its data type will be an integer represented by int. And this will be the primary key of the table. Next column, we have the name. And since it's text, the data type will be a varchar. And I don't want it to have more than 100 characters. In our next column, we have the department column. And since it's a text, the data type will be varchar, and I don't want it to have more than 50 characters. And then in our next column, we have the manager ID. And since it's a number, its data type will be an integer. So we introduce the foreign key. The foreign key is the manager ID. And its references will be from the employees table, and that will be the employee ID. So highlight your query and execute it, and voila, our command has been completed successfully. On to our next segment, I want us to insert sample data. And now, I want us to add data to see self-join in action. And to insert data into a table, we use insert into. We are inserting into a table, and our table name is called the employees. And we are inserting values into this table. So my first row will have, so the employee ID is 1. Let's open our brackets. The employee ID is 1. The name is Priya Patel. The department is engineering. And then the manager ID is null because we do not know the manager ID. So close your bracket and put a comma. Next row, we have the employee ID will be 2. The name will be James Lee. The department will be marketing. Then the manager ID will be 1. The next row, our employee ID will be 3. The name will be Maria Garcia. The department will be engineering. And then the manager ID will be 1. On to the next row, our employee ID will be 4. The name will be Tom Wilson. The department will be sales. And then the manager ID will be 2. On to our next row, we have the employee ID will be 5. The name will be Emma Davis. The department will be HR. And the manager ID will be 3. Close your brackets, finish your query. But before we do that, I want to explain, right? 1, we can see Priya Patel has a null manager ID. Means that Priya Patel is the CEO. That means she has no manager. 2, we have the manager ID to be 1. James Lee reports to Priya. Maria also reports to Priya according to the manager ID. For Tom Wilson, we can see that he reports to James. And then finally, Emma Davis reports to Maria. So we can finally highlight our query and then execute it, and voila, 5 rows have been affected. So on to our next segment, I want us to write a self-join query. Here, the key syntax for the self-join. We alias the same table twice to compare it to itself, okay? So we will write select A, that is the name column, and its alias as employee. Then also B, name column, its alias as manager. From the employees table, that is A, then we want to join the employees table with B on A, the manager ID, the one that brings the relationship between the two tables. And this we equate it to B, the employee ID. Okay? So let us highlight it, then execute it, and voila! Can you see how this pairs each employee with their manager? Like you can see James Lee has Priya as the manager, Maria with Priya, Tom with James, and Emma with Maria. But wait, Priya, the CEO, is missing because she has no manager. So let's fix that, okay? So in our next segment, I want us to include null, or in short, unmatched records. So to show all employees, even those without managers, use a left join instead. So I want us to write this down by starting with select A as the name, and its alias will be employee, comma, B, name, its alias is the manager. All this is gotten from the employees table, and this will have an A, and we want to left join the employees table, that is B, on A, the manager ID, which we will equate it to B, employee ID. Now highlight your query and then execute it, and voila. Now, as you can see from my screen, Priya appears with a null manager, just like real life. On to our next segment, I want us to find hierarchical relationships. And this, we are going to go deeper. So what if you want to find employees who share the same manager? So we will write it down as select A, that's the name, as employee 1. Then B, the name column, as employee 2. Then C, the name column, as the manager. And all this is from the employees table, that is A. Then we want to join the employees table, that's B, on A, the manager ID, and we equate it to the B, which is manager ID, and A, employee ID, which is less than B, employee ID. And we also want to join employees table, which is C, on A, the manager ID column, and equate it to C, the employee ID column. So highlight your query and then execute it, and voila. Now we see pairs like James and Maria, who both report to Priya. Can you see that? In our final segment, I will teach you about the real world uses. So when should you use self-join? 1, organization charts. Who reports to whom? 2. Product hierarchies, which items are in the same category. And finally, network analysis, friends of friends in social networks. So guys, that was very, very simple. And that's the power of SQL Self Join. Now you can analyze relationships within the same table like a pro. So if you found this video helpful, don't forget to hit the like button and subscribe for more future SQL tutorials. If you have any suggestions for future videos, don't forget to drop it in the comment section. So until next time, happy coding!